Hey everyone, it's been a while since I posted any video that I recorded. So let me start with capital budgeting or capital investment financing. So when you are financing a capital investment, you are either borrowing money from a bank and you have to pay some interest on it, or you are using your own funds, which has an opportunity cost. That means the fund could be invested in a risk-free market for a specific percentage. So either one of this is your cost of the fund, which you will read more in your cost of capital topic. So before getting into further capital budgeting, let me give you a quick background to the calculations. Suppose you have 1,000 rupees and you are investing it at 10% per annum. So in capital budgeting, normally today is referred to as time zero or year zero. So year one, what will be the principal? I'll probably move this a bit up. So at the end of 1 year, principal continues to be at 1,000. Interest for that 1 year is at 100 rupees, 10%. So your total balance at the end of year one is 110. So the other way of calculating this is 1,000 into 1 plus R, or the rate of interest, which is into 1 plus 0.1 or 0.1. 10% is nothing but 0.1. So if I convert this into a calculation, star 1,100. So that's what is happening here. It's nothing but 100 into 1 plus that's the asterisk. Okay. Now let's go to year two. What was my opening balance? Had 1,100. Interest 10%, 110. Balance 1210. Year three, one two one zero, 121 interest, 1331 is the balance. Now after 3 years you have 1331. What have we done? 1,100 into 1 plus R. Next year 1210 into 1 plus R. So 1100 is 1 plus r times 1000. 1000 into 1 plus r. We have done that 3 times. So instead of doing it this way, a shorter option would be 1 plus r to the power 3, because 3 times you are doing it, 1 plus r, 1 plus r, 1 plus r. So to the power 3, if you do the calculations, 1000 into 1 plus 0.1 to the power 3, 1331. This you would have read in your school math as amount is equal to amount A is equal to principal into 1 plus r power power t, or number of years, n. P into 1 plus r by 100 power n. R could be written as a decimal, so 1 plus r power n. This is called compounding. Moving forward, charging interest on interest every time. So you have 10% interest, and this 10% is not simply applied on the principal but also on the accumulated interest. Now the reverse of this, or the opposite of this, is discounting. I'm using the usual antonym sign we used in our school days. So the antonym of compounding is discounting. Now let's start with year 3. How much did we have? 1331 at the end of year 3. To come to year 2, the balance, this was the amount, interest, balance. What was the interest in the third year? It was 121. So the balance was 1331 minus 121, 1210. But how to get that 121? So 1331 was some principal x, interest, so let's call P, rate of interest is just R. So principal, we don't know the principal. This principal into rate gave us 121. And so P plus P into rate. So amount is P into 1 plus R. So that's what we saw here. P into 1 plus R gives us 1331. So just doing that again. Now if I have to, now I have the amount, which is 1331, and then I know the rate. %10% or 0.1. So to find the principal P, all I have to do is 1331 divided by 1 plus 0.1 or 1.1. So 1210. So the balance divided by 10%, 1.1, and the interest is nothing but into 0.1. Now this becomes the closing balance of year 3. So closing balance will be year 2, 1210, and the opening balance, again applying the same formula, closing balance into closing balance divided by 1 plus interest rate. So moving forward, we on the opening balance we multiplied by 1 plus interest rate to get the closing balance. So from the closing balance, if you divide by 1 plus interest rate, you get the opening balance. So similarly, year 1, $1,000 is the opening balance, or this is our year 0. That's it. So what have we done here? Closing balance closing balance divided by 1 plus interest rate, closing balance divided by 1 plus interest rate, closing balance divided by 1 plus interest rate. 3 times, because the number of years is 3. So this can be easily done using a single click. 1331, the whole thing divided by 1.1 power 3 times 1000. So whatever be the rate, say rate 12%, years 7 years, final balance at the end of 7 years, say is 1,45,000. Present value of that future balance. If the future amount is 1,45,000, today it is the whole thing divided by 1 plus rate of interest to the power number of years. So if you put 6,55,090.64 today at 12%, it becomes 1,45,000 at the end of 7 years. Or if you're going to get 1,45,000 at the end of 7 years and your borrowing cost is 12%, then in reality the present value after adjusting for all the interest payments you have to make on that is only 65,590. Or see, there is a cost to money, interest cost. Suppose I have 50,000 today, I can invest it meaningfully in some fixed deposit. So today's rates are very low, but still say it's 5%. So suppose I can current interest is 5%. Then if I have this money, 1,03,000 today, if I invest it at 5% for 7 years, I'll get 1,45,000 at the end of 7 years. So somebody says that I'll give you 1,45,000 at the end of 7 years. The real value of that money today, or the present value of that money, is only 1,03,048. That's the discounting, bringing it to current value. So why am I talking about discounting in detail? So we'll go to a simple capital budgeting problem. Investment initially is say 1 lakh. I have put a minus sign because it's going out of our hands. This is year 0. 0. Just taking some random numbers, and 50,000. So since it's a random, it keeps changing. Let's freeze it. I've frozen it. And the rate of borrowing is say 8%. I borrowed at 8%. So what you get at the end of 1 year is to be discounted by 8%. So 1 plus 0.08. Since it's only 1 year interest, I just use the power 1. So what I get at the end of 1 year, though it is 12,857, if I discount it at 8%, today's value is only 11,904. Cost. Cost of capital, or your borrowing cost. Present value, since it's year 0 today, there is no change in present value. Next year, just since I've used a formula, power 2. Whatever I received, since it's after 2 years, I have to bring it down to today's terms. So I discounted 2 times using 8%. So the same way I'm doing it for all the years. So this is my PV of outflows. PV of inflows. If you notice, I've excluded that 1 lakh investment. So the net present value is 37,722. I invested 1 lakh, and after adjusting for my cost of capital at 8%, I got back 1,37,000 in today's terms, present value terms. So my net present value, which is present value of inflows minus present value of outflows, is 37,722. So we'll continue with more concepts on capital budgeting in the next few sessions. Thank you.